have to click on the link if you don't want to.
I already did.
Because I'm going to share. Gotcha. Okay, let's see. Hey, Meche, how are you? Okay, here's my icebreaker for y'all. So assume it's your turn to make dinner tonight, and you got to make dinner for maybe your family or your friends. What meal would you make? So like, what's your meal that like, okay, I know how to make this. And just assume that you have the budget to make it. So you can go to the store and get the groceries for it. What's like a meal that you're proud of that you're like, okay, at least I can make this? Because for me, it's not much. I'm not a very good rice bowls. Oh, y'all are making me hungry. It's about lunchtime. Shrimp pasta, Cajun shrimp Alfredo pasta. This is making me so hungry. That all sounds so good. Those sound so good. I can't believe y'all can make that at this point. Taco Bell. Okay, I love that, Landon.
Okay, it will take me forever to type this out, but my mom kind of invented something. It's called Piper Surprise, and I know how to make it. So it's it's comprised of peas, corn, the mac and cheese, but without salt, pepper, or butter, because there's already a lot of that in the rest of the stuff. You dump it in, and also cream and mushroom soup.
Ooh, that sounds actually really good.
You dump all that into a pot, and then you pour milk into it, but to the point where it just starts showing up on the sides. And then you put it on low heat, and you let it, and you let everything simmer.
That sounds so good, Piper. Wow, that's delicious. And I'm loving some of these other responses too. Hold on, let me read through some of these. Megan, I'm with you though. I can make dessert. I can make like bread or anything like bread based. I make all the time, like twice, 3 times a week at least. I'll make like batches of stuff, but I am not very good at making dinners. Samantha, you can make fish. I didn't see that. Gabriel, chicken, rice, and vegetables. Braden, cup of ramen. I love that. Gideon, breakfast for dinner. I love making breakfast for dinner because I can make homemade waffles, and I love doing that. Enchiladas, that's really good. Maybe pizza. Eggs, I do eat eggs a lot. Crepes, that sounds so good, Emily. Breakfast for dinner, love that. Fettuccine Alfredo. Chicken, cheese, rice, casserole, or taco soup. Y'all, we need to just combine all of these recipes. I need to get all these recipes from y'all. Grilled cheese, tomato soup, cookies and ramen. Okay, I love it. Tacos or quesadillas, breakfast for dinner. All right. Chopped up hot dogs with mac and cheese. I've heard of that before. I've never tried it, but I've heard of it. Man, we've got some good chefs here, and I have the wheel spinning for what I'm going to have for lunch because of you guys. Here is the link. If you guys just joined, welcome to chemistry class. If you click on this link, you'll have access to the slides for today. So let's see. Today, we're going to talk about basically just like the periodic table and a little bit more about electron configuration. We did talk about it last week as well, but we'll talk about it again. But before we do that, I want you all to know, think about where you are. Think about what lesson you're on in chemistry, okay? If you are somewhere in Unit 2, you're invited to join at 1 o'clock today for just a knockout session of Unit 2. Some of you guys have different paces on your, if you are a newer student, you probably should not be on Unit 2. But if you've been here since August, you should be done with Unit 2 and working on Unit 3. But it kind of depends on the student. So that's like a general thing you can see on your list. But we're going to have a knockout session today at 1 o'clock, and I'm going to help you get through it quicker, help you with the parts that are confusing to you, and there will be other students who join. So at 1 o'clock, come to knock out Unit 2 if that's where you are. And if you are on Unit 1, Lesson 3, this is for students who may have joined more recently. Lesson 3 is a longer lesson. We're going to have a knockout session at 3 o'clock. So if you are on Unit 1, Lesson 3, you can come at 3 o'clock to that. Okay. I'm loving these comments. Y'all are still telling me about your favorite meal. I love this. You put mayo on your mac and cheese. Ooh, it's interesting. That's interesting. Okay, again, I wanted to remind you, if you're new, click on this link and download a periodic table. If you can print it, that would be awesome. If you cannot print it, that's totally okay. There is a colored version and a black and white version. To be honest, I think the black and white might be a little bit simpler. So, Letty, if you're on Unit 3, you can join anytime. So these sessions are like, just like for students to come to kind of help gain momentum, but you are always welcome to come anytime during the day for help on your unique lesson. So if you don't fit into this category, if you'd prefer to just work with me, I'm in my classroom until 4 o'clock and you can come in anytime. So download this periodic table to your Chromebook and save it, and then you can refer to it later. If you can print it, that would be awesome, because then you can write on it so that you have stuff, because the periodic table will be used over and over and over again. And you also will take chemistry in the spring and you're going to use it again over and over again. So if you have the ability to save it and write on it, that would be awesome. But you can do it in multiple ways. Like you can save it to your computer if you'd rather do it that way. And then Adam, you can print it if you have a printer, or you can still use it on Windows. I think you can download it to your computer, if that makes sense. Let's see. All right, next thing real quick is click on this link right here in the slides. Click on this link, and this is save it to your drive. This is the chemistry resource folder, and I continually update it with resources for each unit, okay? Yeah, Eden says you can also bookmark it or make it a favorite, yeah. So click on that link. I put it in the chat there, but it has, I kind of notice where most students struggle, and I put resources together for it. I explain how to do it, or I put a tutorial video online. And so the chemistry resource folder is right there, and you can click on that. Okay, so if y'all remember last week, we talked about this weird thing called electron configuration. Do y'all remember that? I wanted to kind of recap what that was for electron configuration. And so when you see something like this, like 1s2, the first number right here is telling you the row, what row it's on. So this is some element on row 1. The next part is telling you what section. So it's in the S section. And then the part after that is telling you how many blocks, like how far in. So like how many blocks in. So 1s2 would be, let's go back. Let's see. 1s2 would be helium, because it's on row 1. And you can see here that it's section S, and then that it's 2 blocks in. Okay. So I wanted to just recap a little bit, because I know it's kind of weird what we're doing. So let's look at phosphorus real quick. If we want to write the configuration for phosphorus, what you do is you start at the very beginning. You start at hydrogen. And then reading from left to right, you list the row, or basically that row is kind of like the energy that it has. So what row it's on, and then the section, and then how many are in that section. Okay, so first we start with hydrogen. So that's row 1, section S, and then there are 2 elements there, right? So now that we're done with hydrogen, we go on to lithium, which is row 2, section S, and there are, again, 2 blocks there, okay? Now we're going left to right, we're still on row 2, but what section is this now? Does anybody know what this green section is called right here? Yes, great job, Megan. Do y'all see right there in the yellow block? See how that says P? Now we're in the P section, and so we're going to write 2p6, because if you count these elements here, there are 6 of them. We're going to cross that out now. We covered all of those. So now we're on row 3, section what? What section are we hitting now? What comes next? We're on row 3. What's the first section or sub-level that's on row 3? So we're looking right here. Great job, Elena. Great job. This is the S section. You'll see this S right here. 3S, and there's 2 of them there, right? 2 right there. And now we're going to go across. We're still on row 3, but now we're on section P, and then we're trying to get to phosphorus. And so we're only going to go 3 blocks in, 1, 2, 3, because we want to stop at phosphorus. Yes, Megan, and we'll talk about that in just a second. Yes, it would be neon. Does this process kind of make sense to y'all on how I'm doing that? Give me a thumbs up or give me a question mark if you're like, huh? Or if this process, you're like, okay, I kind of see what we're doing here. Sorry, I think a student's calling me, but I'll wait on that. Give me 1 second. Okay, makes sense to y'all? Okay, we'll do one more practice real quick. I know this is kind of weird, but it's going to come up multiple times. And so I want to make sure that y'all do understand it, okay? For W, we have to do all the way down here, right? So with W, we're going to start at hydrogen again, and we got to go all the way down to W, okay? So we're going to list the row, the section, and how many. So starting at row 1, that's section S, and there's 2 of them there, right? And now we're on row 2. There's the S section, there's 2 of them. And then there's the P section, and there is 6 of them, right? You see how I'm crossing them out as I go? Now we're on row 3. In the first section here, you'll see how it says S, and there's 2 of them, okay? And then after that, there's the P section, which is 6 of them. And then after that we're on row 4 right here, right? And what section is on row 4 right here? What's this section? What's this sub-level called right here? What's this light blue section called right here? Anybody know? You can look at the yellow block right here. Yeah, 4S, right? So that's 2 of them there. And then here is something important for your test, okay? When you are in this, you see how this is the D section? If you look at my arrow, this is the D section. When you're on the D section, the row goes down by 1. So even though we're on the 4th row, the D section shifts down by 1. And that's because what we figured out is that those elements just tend to have a lower energy. And so we bring it down by 1, okay? So 3D10, right? And then you go back up to 4 for the P section again. So you can see that we go back up to the P section here to 4. So only the D section goes down by 1. 5S2 is the next section here, and then 4D10, and then back up to 5P6. And then now we're on the last row here. We're on the 6th row, and the first section is the S section, so 6S2. But something weird happens right here, and we're going to like hop over LA for a second, and we're going to take care of this section right here. If you notice, it's called 4F, so it goes down by 2. And if you count all the elements there are 14 of them, right? There's 14 of them there. So that's called 4F. Now we're going to go back up to the D section, and it's called 5D. And we're going to count how many it takes to get to tungsten, to W right here. And it takes 1, 2, 3, 4, right? And so I know this is really long. It's this long coding for it, right? But you're kind of just listing the row, the section, how many every time, right? So I know this one was longer, but hopefully you're kind of seeing that there's like some trends on how you do it, and it gets easier as you understand how to write that coding out. And what Megan was mentioning earlier is there is a way to abbreviate, okay? There's a way to do this much quicker, because how many of y'all want to write that out? Like, look at how much we had to write there. Well, we can save ourselves a lot of time using the abbreviated or the shorthand way. So everybody look here. What are these called right here? What is this box right here? Anybody know what this family is called? Great job. Great job. Noble gases. Have y'all heard of noble gases before? Some no, some yes. Anybody else heard of noble gases? Okay. If you have not heard of noble gases, you need to know this last row is like really important, and they're called noble gases. And basically they are called that because they are the kind of the optimal family. They're noble. They don't really interact with other elements because they're already happy and they're already stable. And so they kind of have a lot of focus on the periodic table because they're so noble, okay? So this last group here, they're called the noble gases. And so if you want to have a shorthand version for W, we need to identify the previous noble gas. So when you look at W right here, what do you think the previous noble gas would be for W? Do you think it would be Kr, Xe, Rn? Which of these elements is previous to W? What do y'all think? Okay, great job. So y'all all look at it here and see if you can identify. So Xe is the previous one. What I like to do is I like to take my arrow and I go over and then I go up one because Rn would be the next one, right? So Xe is the previous one. So you identify the previous one and you put it in brackets like this right here. And then when you do that, you can slash through everything up to Xe. So you don't have to write any of the stuff before Xe. Okay, so it's like you're slashing through all of that. And now we just start where Xe leaves off. So we start on row 6 and we write the 6s2 and then the 4f14 and then the 5d4. So you find the previous noble gas and then you just have to start where that one left off. And you just save a lot of space because you've already crossed out everything before it. Does that kind of make sense to y'all, or do y'all have any questions on that? I know it's a little bit like, it's a lot of information about how to write this out, but hopefully this will help y'all out. I know it's a really cool thing. I love that we have that rule that we can abbreviate. Is that making sense to y'all on how to do it? I don't know if I have another example here. Awesome, awesome. Okay, one other thing. I don't know if y'all saw this picture, like stuff like this on your tests or on your quizzes. This is called orbital notation, and I'm going to show you guys a hack for how to do this really quickly, okay? So orbital notation is like another way of writing this out. And rather than teach, like I would love to teach you guys this personally if you're interested in learning it. But for now, I'm going to kind of teach you how to quickly look at this and figure out what you need to figure out, okay? So basically, as a quick trick, when you're doing an orbital notation problem, okay, the number of arrows should equal the number of electrons, okay? So for example, lithium has 3 electrons, right? And look at how many arrows it has. 1, 2, 3, right? So the up, down, up, you count each one. And so lithium has 3 electrons, it's gonna have 3 arrows. Beryllium has 4 electrons, and guess what? It has 4 arrows. Boron has 5 electrons, and if you count these arrows, there are 5. So on your quizzes, on your tests, on your lessons, when you look at orbital notation, count the arrows, and the arrows need to match the number of electrons. Does that kind of make sense to y'all on how to do that? I kind of wanted to save some time on that because you already had to learn about electron configuration. So I think as long as you kind of know that, I kind of wanted to teach you guys the trick for orbital notation. Yeah. Sometimes the lessons are confusing on how they teach things. And so I really like, if you come, I'll try to explain it in a different way and to simplify it because there's just so much words, you know, that it can be overwhelming on understanding it all. Okay. Now we get to talk about the fun stuff because we did all kind of the work just then. And so we're just going to talk about how the periodic table got formed. I want y'all all to look at this picture right here. This picture, like the periodic table that you and I know is not always like there were other options, right? And so one person decided, okay, maybe the periodic table should be arranged like this. And then another person decided, well, maybe it should be arranged like this. So as the periodic table was getting developed, there were different like areas of thought of like, how should we arrange them? Should carbon be next to oxygen or should carbon be next to nitrogen? So there were all sorts of cool, weird periodic tables. Look at this periodic table. This is another form of a periodic table right here. You can look up all sorts of cool ones, right? And they're just organized in different ways. Isn't this weird? This could have been our periodic table right here. How much more, it might have been more confusing, but it's kind of cool at the same time, right? Here's another periodic table here that I found. Look how weird that is. It reminds me of like a weird board game. For some reason, this reminds me of the game of life. I don't know why it reminds me of the game of life, but something about it We need a chemistry board game. That would be fun. Okay, but just to talk about the periodic table, as scientists, like think about the first scientists who started discovering elements. As they discovered elements and they started kind of putting them together, they noticed some patterns, and we call that periodicity. Periodicity, if you can say that fast. Some repeating patterns. The first guy who found some patterns, his name was Dmitri Mendeleev. He started piecing together the periodic table, and he noticed that when he arranged them by their weight, like as the weight increased, he put them next to each other, he noticed that there were some repeating patterns. And so he made this periodic table right here, actually. This is his discoveries. These were all the elements that he discovered, that he was piecing together. And he noticed, like, okay, if I keep increasing the mass going across like this, starting with sodium right here, Na, Li and Na kind of act the same. And so he noticed this repeating pattern. And every time there was a repeating pattern, he started a new row, right? So he kept arranging them by mass. And every time there was a repeating pattern, he started a new row. So everything in this column kind of acted the same way. And everything in this column kind of acted the same way. And then he started noticing these gaps. Basically, he figured out maybe that element just hasn't been discovered yet. And so he would leave that gap there thinking, okay, maybe somebody else will discover this element. So it was really cool. He kind of started piecing together things on the periodic table. The problem was his periodic table wasn't perfect. He ordered them by mass, and that would often kind of mess things up. Most of the time it worked, but there were a lot of exceptions. So this guy, his name's Henry Moseley. Look at this cool picture of him. He came in and he was like, okay, Mendeleev, you did a lot of work, but I think that we should order it by their atomic number, not by their mass. And he figured out, okay, if we arrange them by their increasing number of protons, it's perfect. Things line up really well. And this fixed all of the imperfections from Mendeleev's periodic table. So Henry Moseley came in and he kind of did the final work of saying, okay, we're going to arrange it by atomic number rather than by atomic mass. And so that's really important to know. That's the way it is today. Elements are arranged as the proton number increases, which is the atomic number. And now we have all these cool elements, okay? So we're going to talk today about some of these elements. So if you look at this picture, you see how like all the other elements are kind of grayed out? So that's on purpose. So I only want you to look at this red part right here. And if you have your periodic table, you can write this in small lettering like on top of that column. Like this entire column is they're called alkali metals. They are group 1 on the periodic table, except hydrogen is not part of them. Hydrogen is kind of excluded from them, but everything else is called alkali metals. These are soft metals that react violently with water. There are some really cool videos of alkali metals reacting with water. Have any of y'all seen videos of them reacting with water? I may have to pull up a video in a minute. Anybody seen a video of any of these reacting with water? I'm just curious who here has like looked a little bit into it before. I'm seeing a lot of no's. Y'all haven't seen that before? You don't know what happens when sodium reacts with water? Okay, I'm gonna have to pull up a video in a minute. Okay, you'll get to see it in just a minute. It's so cool. We'll come back to it. But basically, they're extremely reactive. They're gonna catch on fire. They're gonna burn. They're gonna explode. They're very explosive. Okay, so alkali metals are group 1. Group 2 are called alkaline with an Ne at the end. Alkaline metals. Okay, so you can label group 2 alkaline. They are less reactive, but they still are pretty reactive. So they will still catch on fire sometimes or react, but it's not as explosive as the previous group. Here are some examples of alkaline earth metals there. And then this middle box, that entire kind of rectangle there, those are called transition metals. Transition metals. And you can put that on your periodic table as well. If you guys like to color, you could color in your periodic table so that you have them all labeled and organized. So these are called transition metals, and we'll talk more about them later. And then this next to last group right here, these are called halogens. halogens, and they're this group right here. They kind of, here are some examples here. They're really reactive and sometimes dangerous, and they combine with alkali metals and alkaline metals to form salts. Some of them are liquids at room temperature, and some of them are gases at room temperature. So they're kind of all different there with those. But like chlorine gas, you know, you've heard of that. That's very dangerous to breathe in. If you accidentally, like you got to be careful using bleach, because if you mix bleach with soap, bleach and soap combine to release chlorine gas, which is really bad for you to breathe in. So things like that, like you have to be careful when you're cleaning, because sometimes you can accidentally mix some chemicals together that shouldn't be mixed together. Okay, this is just more examples here of halogens. And then the last group, like we talked about, they're called noble gases, which is this group on the periodic table right here. Noble gases are very stable. They're low energy, and they have a full shell. They are inert, which means they don't form compounds with other elements. Inert kind of means that it's safe. It's unreactive. So an inert gas is not going to really hurt you because be reactive or explosive, because it's very stable already. So those are noble gases. So yeah, that's the main stuff that I'm going to talk about today. If you guys have any questions about anything we went